Hello friends, welcome you in this video where we learn interfacing of keypad with Arduino. A key is a mechanical device that is used for making and breaking contact between two terminals. So it is a simple mechanical device that makes and break contact between the input and the output. So I have shown you a simple push button key. You have often seen this type of push button key in various applications. This type of key is used in day-to-day life. Also we use certain keys for making and breaking the applications, particularly the electrical application. The number of keys are arranged to form a keypad. So number of keys are arranged in various formats to form a keypad. Now a keypad is an input device that is used to enter data into the computer system, enter passwords, dial numbers, browse through menus, and even to control various systems. So this is called a keypad. Keypad can be used with microcontrollers and prototyping platforms like Arduino to implement variety of projects. So with the help of microcontroller system and this Arduino system, we can use this keypad as an input device to enter various data. There are two types of keypad. One is a matrix type keypad, another is non-matrix type keypad. Okay. So in matrix type keypad, the keys are arranged in a matrix format. Like in mathematics, we see a matrix. So like that, the keys are arranged in that matrix format. And the non-matrix type keypad is very simple, that it is not arranged in a matrix format. So that means each key is connected to a particular pin on the Arduino or any microcontroller device. So whenever that key is pressed, that key make the contact with the ground. So this is a simple principle for non-matrix type keypad. But generally in most of the cases, matrix type keypad is used. Why? Because the matrix type keypad uses less number of pins as compared to non-matrix type keypad. So we focus here on matrix type keypad. So matrix keypad is a systematic arrangement of keys in horizontal and vertical fashion. For example, here I have shown 3:3 matrix type keypad consists of 9 keys that are arranged in 3 rows and 3 columns. So this is an example I have shown you. The push button. These are the 1, 2, 3, 4, 5, 6, 7, 8. These are the 9 push button keys which are connected to particular column number C1, C2, C3 in particular rows R1, R2, R3. So this form a matrix. So we can say it is a 3:3. That means there are 3 rows and 3 columns. So that's why it is called 3:3. So there may be 4:4, there may be 4:3, there may be 5:4. So number of keypads we can make by using this matrix type format. Now how it works? Matrix type keypad, how it works. So let us see point by point. These are the row pins R1, R2, R3, and these are the column pins C1, C2, C3. These rows pins are often called return lines and the column pins are called scanning lines. So let us see it's working. First point, all rows are made low and all columns are made high by the help of microcontroller. So these row lines we have to make low and the column lines we have to make high. This can be possible with the help of sending signal using microcontroller or Arduino. When no key is pressed, this will be the default status of rows and columns. No key pressed, there will be a default status. That means this will be at 0, this will be at high. Now when a key is pressed, the corresponding column will become low as the current flows from high column pin to low column pin. So when any key is pressed, suppose for example key number 4 is pressed, so that makes this column C1 becomes low. Because it is at low and the column pin is high, when key is pressed, this becomes low. And that will be scan by the scanning lines. Microcontroller Arduino can easily identify the column of the key just by scanning for low on columns. So this will always scan for these lines. If it becomes low, then it will scan it and it will send the data we have entered for this key. For example, if you enter 4 for this key, so 4 will be entered into the microcontroller system. So this is how matrix type keypad works. Okay, now let us see the interfacing diagram of this keypad to the Arduino. So we have considered here 4:4 keypad. So there will be 4 rows A, B, C, D and 4 columns 1, 2, 3, 4. So this we have to connect to this Arduino. So while connecting this, we have to connect. There are total 8 pins will be required, and that will be digital input output pin. So here I have considered row A, B, C, D, which are connected to pin number 0, 1, 2, 3, 4 respectively. And the column pins of this keypad 1, 2, 3, 4 are connected to the digital input output pins 4, 5, 6, 7 respectively. So this is how simply we have to connect this keypad to the digital pins of this Arduino. Now I have also connected here 16:2 LCD module. So why this module is connected? Because we have to see the characters we have assigned for this keypad, that we have to see on this LCD module. So that's why we have to connect it. We can also see the character placed on the serial monitor, but for understanding we have connected here LCD module. So we have assigned here, these are the digits 1, 2, 9, 0. There is a on button and some multiplication, positive, minus, division signs here. So this we have to assign in the program. Okay, so this is interfacing diagram of this keypad. Now let us see algorithm for this keypad interfacing. So in algorithm, first point is to include the library functions. So this library function we have to include for LCD and keypad. So these both library function will include here. Then configure the LCD interfacing with Arduino pins as given below. So we have also seen in last video this pin number 8, 9, 10, 11, 12, 13 that we have to connect respectively register select pin, enable pin, data pin D4 to D7 of this LCD module. So these pins we have to connect to this LCD module for making LCD workable. So then define number of rows as a 4 and number of columns as a 4. So we have to define the keypad as a 4:4 matrix. Define the key map for each key pressed to that key map in matrix form. That key map we have to define. That means which key and what character we have to assign for that key. So this is called key map. Configure the keypad row pins, column pins interfacing with the Arduino pins. Then like this we have to configure row pin 1, 2, 3, 4 pin number 0, 1, 2, 3 and column pin 1, 2, 3, 4 to pin number 4, 5, 6, 7 that we have to configure here. Then initialize an instance of the keypad class by passing keyman. So this row pin column pins we have to initialize the keypad. In setup function we have to set up LCD number of columns and rows. So it will be 16:2 print a message keypad interface and set cursor on the second line. In second line we have to press which key pressed, that character we have to see on the second line. In the loop function we have to declare character variable to hold the key value and then get key pressed, which key is pressed that we have to display, and it will clear the first key or first character and then write another character, display the value on the key on LCD, right? So this is the algorithm for keypad interfacing. Now see the actual sketch hash include. So we have to include these libraries, liquid crystal and keypad. These both libraries we have to include here. Then initialize library with boolean number for interfacing. pin. So liquid crystal LCD 8, 9, 10, 11, 12, 13. So we'll initialize the liquid crystal pin numbers. Now we have to set for keypad. Number of rows 4, number of columns 4. We have set here. Then key mat we have to justify. So as per our keypad, we have shown in interfacing diagram. So according to that means here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This multiplication positive sign on. So this we have to define as per interfacing diagram. We have defined this in matrix form. This is called key map. Then number of pins we have to define more particularly 4, 5, 6, 7 rows and columns 0, 1, 2, 3. And then we have to use this syntax for getting key pressed. In void setup, we'll begin LCD, print a message on that LCD, and in void loop, we'll get the key pressed. If key is pressed, then clear LCD and then write the key pressed. So what is the key? Assign character. That character will be displayed on the LCD module. And when you press another key, so it will first clear the previous character and then it will write another character. So this will be continuously in loop. So whatever the key we press, it will display on this and the first character will be erased. So this is the simple keypad interfacing program. So in this video we'll see up to this point. Hope you understand. If you have any doubt regarding this, comment me. Thank you for watching this.